Look around your room. The screen, the chair, the floor beneath your feet. Our senses report these things as solid, stable, and tangible. We live our lives within this baseline assumption of a material world. However, the development of modern physics has provided a different account. The data suggests that our intuition about the nature of solid objects is inconsistent with the way the universe actually functions. Max Planck, the father of quantum theory, encountered this inconsistency while investigating the behavior of atoms. He eventually stated that matter, as we typically conceive of it, does not exist. Planck's research led him to conclude that what we call matter is actually the result of a force that brings subatomic particles to vibration. He theorized that an underlying, intelligent spirit acts as the matrix for everything we perceive as physical. If you increase the magnification on any object, you don't find smaller pieces of stuff. You find atoms that are 99.9% empty space. Go deeper, and the particles themselves dissolve into immaterial waves of probability. This leaves us with a specific question. If the universe is not comprised of physical matter at its most basic level, what is the substance of our reality? To find the answer, we have to look at the microscopic scale, where the rules of classical physics begin to fail. The double-slit experiment reveals that a single particle, when unobserved, travels as an expanding wave. It passes through two openings simultaneously, interfering with itself to create the pattern seen here. Erwin Schrödinger formulated the wave function to describe this. It defines a particle not as a localized object, but as a smeared-out field of possibilities. The introduction of a measurement changes the outcome. The act of observing the system causes the wave function to collapse, forcing the particle to take on a single defined position in space. This process mirrors the way a video game engine manages data. The software only renders specific assets when a player's field of vision is directed toward them, conserving the system's processing power. The data from the quantum levels suggests that physical reality requires an interaction to manifest. It does not appear to exist in a fixed, solid state independently of an observer. Scaling up to the cosmic level reveals that space itself shares this lack of solidity. Albert Einstein famously questioned the phenomenon of quantum entanglement, calling it spooky action at a distance. He struggled with the fact that two entangled particles can influence one another instantly, regardless of the distance between them. This instant correlation indicates that the physical distance between objects is not a fundamental barrier. Information is traversed instantly, bypassing the limitations of three-dimensional space. Physicists have used black holes to test these limits. They discovered that the entropy, or the total information content, of a black hole behaves in a highly counterintuitive way. Research shows a black hole's information isn't stored within its 3D volume, but encoded on its 2D surface. This holographic principle suggests our entire 3D universe, planets, stars, ourselves, is just a projection emerging from a 2D boundary of space. In this framework, space and time are not the floor of reality. They are emergent properties of an underlying information processor. While our technology for measuring information is new, the idea that reality is derivative of a non-physical source dates back thousands of years. The ancient occult philosophy of Hermeticism recorded this conclusion as its first pillar. As stated in the Kybalion, the all is mind, the universe is mental. This principle posits that the universe is an immaterial construction